Now we're going to hide the thing here. Okay, right. So we have two graphs. Both
Yep.
of these graphs, they show the velocity versus time. So whenever you look at the graph, you have to be very careful. You look at the label on the x-axis and y-axis, whether it is velocity, position, or acceleration. So in this case, it is velocity. Okay, we have again for the velocity time graph, we have three sections. The first section goes up, then flatten, then come down again. Okay, so can you remember go up means what? Go up with a straight line means what? Flatten means what?
Acceleration and constant.
The first part, acceleration is constant. The second part, the velocity is horizontal. It is not increasing. So what is the acceleration?
Zero.
Correct. The velocity, the acceleration is zero. Correct. So when you look at this graph here, before you calculate using the formula, roughly what can you say about this part of the graph? The first part of the graph?
Accelerating.
Yes, it is accelerating, and because the velocity is increasing, it is accelerating. It is accelerating at a constant rate. It is accelerating at a constant rate. That means the acceleration is not increasing. Now for the second part here, for the second part, the horizontal part here, what
Okay.
is the velocity? This part, the horizontal part. Is it increasing?
No.
No, because this part is increasing. This part, the velocity is not increasing, right? So if there
Mm-hmm.
is no increase in velocity, what is the acceleration? No increase.
Zero.
Correct. The
No.
acceleration is zero, right? Then for the last part here, for the last part here, what is your prediction? What can you say here? What happened to the velocity? At first it's very high, then come down like that. What happened to the velocity? Increasing,
It's decrease.
decreasing, or constant?
De-
This part.
Decreasing.
The velocity is increasing from the top until the bottom here. The velocity is increasing, decreasing, or the velocity is constant.
Decreasing.
Decreasing, correct. So if you come down like that, that means the velocity is decreasing. If the
Mm-hmm.
velocity is decreasing, what can you say about the acceleration? Velocity decreasing.
Slash
Positive or negative?
negative.
Negative, correct. So actually, the velocity decreasing, it means that the acceleration is negative. Now, can you use the formula for finding the slope of this line here? Can you find the slope of this line? You use this point here. 4, the velocity 4, velocity 0, divided by the time 2 minus the time 0. Okay? So we use delta V over delta T. So what
Okay.
is the delta
Okay.
V in the A part, this section A? What is the delta V? V1,
Uh,
VF, VI. VF,
four.
how much is the VF here?
Four.
4. How much is the initial velocity here?
Two. Zero. Right?
0.
Two. Two. Two.
So
Two.
you
Two.
use 4 minus 0. So 4 minus 0. So what is the difference in time? What is the time interval for this part?
Two.
The time interval, this is the velocity, this is the time
Mm-hmm.
interval. The horizontal one is the time interval. It is 2 minus 0.
0.
So
So 2
4 minus 0, 2
over 2
minus
minus
0.
0 is
So
2.
answer is what?
2.
The answer, the average acceleration is, or the
2.
instantaneous acceleration is positive 2 meter per second, right?
Mm-hmm.
For part B here, what is the delta V?
4.
No, the delta is not the V, the delta V. The VF minus VI.
4 minus 4.
4 minus 4, correct, is 0. What is the delta T for this part here? What minus what?
3 minus 2.
3 minus 2, correct. From here to here is 3 minus 2. So it's actually 4 minus 4 over 3 minus 2. 4 minus 4 is already 0. So when you divide by 1, it
Divide by
is
1 is 0.
0, correct. So the acceleration is 0. Because the velocity is constant here, so the acceleration is 0.
Okay.
Here, the velocity is positive because it's going up, it's positive. And now you look at this part here. Can you find the instantaneous velocity at C here?
2
What
minus
minus what
4.
over what minus what?
2 minus 4.
2 minus 4 over
4 minus 3.
4 minus 3. So actually, you are finding the slope of the line. You are finding the slope of the line. And the slope of the line is actually the acceleration. Now,
Okay.
for this here, for this one, the second graph, the B, graph B, can you find the acceleration for this part A, part B, and part C on your own? Then you tell me what's the answer. The answer is hidden here. Can you find by your own? Let's say try part A first. Try to find the acceleration for part A using this formula here. So using this one as the guideline, you try to tell me what is the slope here.
It will be, since it has to be a negative, it will be 1 minus 4 over
Correct. 1
1
minus
minus
4 over.
4 over 1 minus 0, which
Correct.
you get
So that will be the acceleration. How much is it?
negative 3.
Negative 3. Correct. Okay. Now what is that's the instantaneous acceleration at the point B?
3 minus 1 over 3 minus 1, which is
Correct.
1.
It's positive 1. It's positive 1.
Mm-hmm.
So positive means the velocity is increasing. Acceleration is positive. Velocity is increasing. How about this one? The C here?
3 minus 3 over
This is 5. 4, 5.
5. 5 minus 3.
Correct.
0.
0. Correct. Okay. So what is the answer here? Correct. So if the line is, if the slope is negative, that means the acceleration is negative. Because it's a straight
Okay.
line, so the acceleration is constant. If the slope is positive, that means the acceleration is positive, right? And because it's a straight
Hmm?
line and it is not the curve, the acceleration is fixed, right? And finally, if
Yep.
it's a flat line, that means the acceleration is 0. Now, can you
Mm.
read this one, the question 2.3?
Can a tangent line to a velocity versus time graph ever be vertical?
what they mean by the line is vertical. Vertical means like this, you know. Vertical means like this.
Uh-huh. That means cannot. Oh.
Huh?
That means cannot.
Cannot lah, huh? Cannot, correct.
Mm.
Why is it cannot? Huh? Why is it cannot? This one is
Because
actually, the
you,
time is
in
2.
order to count,
This one, the
in order
time
to
is
calculate, you
time is 2. The velocity is how much? The velocity is 5. Okay, let's say the velocity is 5. Right? So at the top, this point at the top here, the time is 2, then the velocity is 5. How about the bottom there? The bottom here, at this point here, the time is 2.
oh,
The velocity is how much? The velocity is 3. So is it possible to have two different velocity at the same time?
no,
No. So
cannot.
that's why it is impossible. That's why it is impossible, right?
Impossible.
So now, with this, we can move on to the graph, right? We move on to the graph. But I clear all this first, clear. Move on to the graph.